Hello there, I am Ümit Alkuş. In this video, we will solve one problem in Chapter 2. A speedy car is traveling at 25 meters per second. A police car starts from rest just as a speeder passes and accelerates at a constant rate of 5 meters per second squared. How fast is the police car traveling when A. It catches up with the speeder, B. It is 25 meters behind the speeding car. For the solution of the part A, first we write the given quantities where C is the abbreviation of car and P is the police. To find the position of the car, we use this formula. Here, AC, which is the acceleration of the car, is 0 since we see, that is, the velocity of the car is constant. And according to our configuration, the initial position of the car is 0. Therefore, we obtain xc at time t1 is equal to vc0 times t1. By the same way, the position of the police at time t1 is found by this formula. We know that the initial position of the police is 0 and the initial velocity of the police is 0. So the result is 1/2 times AP times T1 squared. To continue, for the police to catch up with the speeder, the positions of the car and the police should be the same. So XP equals XC, or 1/2 times AP times T1 squared equals VC0 times T1. From this, we find an expression for T1 as 2VC0 over AP. With the corresponding numerical values, we obtain 10 seconds. Well, the velocity of the police at this time is found by this formula. Here, VP0, that is the initial velocity of the police, is 0. Then we obtain AP times T1, which is equal to 5 times 10. Then the result is 50 meters per second. Or if we use the formula for T1, we have VP equals AP times 2VC0 over AP. Here APs cancel each other, then the result is 2 times VC0. Then 2 times 25 meters per second, so the result is 50 meters per second. From this fantastic formula, you see that whatever the acceleration of police, its speed is twice that of the car. To solve part B, again we write the given quantities. Similar to the procedure used in part A, we find the positions of the car and the police at time t2. As a result, we obtain xc2 equals vc times t2 and xp2 equals 1/2 times AP times T2 squared. At this time, the distance between the car and the police is 25 meters. If we put the corresponding expressions in this formula, we obtain VC times T2 minus 1/2 times AP times T2 squared, which is equal to 25. Since VC is 25 meters per second and AP is 5 meters per second squared, we obtain t squared minus 10 times t2 plus 10 equals 0, which is a second order equation in t. Consequently, the solution becomes 8.8730 seconds. Finally, at this time, the velocity of the police is found by this formula. Here, the initial velocity of the police is 0, then we obtain AP times t2. If you put the corresponding values, we get approximately 44.4 meters per second. Okay, that's all about this problem. Thank you for your attention. See you in the next video.